So without further ado, I'll bring up Michael.
Hey, how's it going? So what do you expect from a title like that, right? Fixing design with tests. So did anybody ever hear that old thing? It's like you can't test in quality. Have you heard about this at all? It's like this old saying that we basically have, and it basically came from the days when, you know, it's kind of like you'd have a separate testing group, and it's like you have the developers, and they're working on things, and then the testers come along, and they're like, here's a problem, here's a problem, here's a problem, here's a problem. It doesn't exactly solve the quality problem, and we know this, right? But a lot's happened since the days when that was like a very popular statement. When I'm using the word fix here, I'm kind of playing a little bit with a couple of different meanings in English. What does it mean to fix something? Okay, so to fix something, if you look in the dictionary, the one that we're commonly used to hearing with fixing is to repair something. Okay, so you have an old computer and you fix it, it corrects its behavior in order to go and actually make it useful for you when you're doing your work, right? But there's another definition, which is kind of powerful as well. It's basically to fasten something in position so it can't move, right? Have you ever heard of this? Fixing something in place, right? And it's interesting because when we think about fastening something, like fastening a door or a windowsill or something like this in a house, we think about pinning down physical structure in a way. And then repairing, we think, is all about behavior. It's kind of like, this computer is not behaving the way I want it to, fix it for me, right? But the thing is that quite often when we're fastening and holding something down in software development with tests, it's to basically fix the behavior, to set things up so that when we make behavioral changes, we know that we've made behavioral changes. If you introduce a bug, the test will tell you, oh, the behavior now is different than it was previously, this kind of thing. And this is a great thing because it's a precursor to refactoring, right? You want to be able to refactor things. You need some assurance that essentially things are behaving now the way that they did previously, even though you're changing the structure. So it's true that we do pin down the behavior. We also have to pin down the behavior through a particular place within the software. We have to figure out what our test points are going to actually be. So yes, we can fix behavior with tests, but I want to go and look at the use of fix in a different way. What if we can actually use the concept of fixing to basically fix design through testing? Does this sound kind of a weird thing? Yeah, it's kind of like we want to be able to fix the design by going and actually executing tests, or actually designing tests, right? So to kind of like approach this, let's go and talk a little bit more about something else. So everybody is used to like unit testing harnesses now, and we're used to all different kinds of tools for testing service APIs and various different things. These all come in very handy. But the thing I think is really kind of powerful for us as developers is to always think of the testing that we do as being something like a read-eval print loop, in a way, right? And here we have a classic one from Python, right? And it's kind of like there's this immediacy. It's like when you're in this, you're able to go and try things out and figure out what's going on with the system. And in fact, if you actually go back to the history of a lot of these things, the first popular, the precursor to the popular testing frameworks that we use today came from one designed by Kent Beck and Smalltalk way back in 80s, 90s. And it was interesting because in the Smalltalk environment, you don't really have a REPL, but you have like a transcript window that shows you, you're typing things in, you get answers. You type things in, you get answers. Pretty much the same as a REPL in a way, right? But the thing is, they were looking for a way to go and actually get that kind of immediacy to understand system behavior, and then go and set that up in such a way that you can repeat it over and over again. And that's essentially what our testing frameworks are now, right? You're able to go and write some questions or something to go and query, interrogate behavior in the system, and you're able to save it and replay it anytime you want to in order to understand things. So it's kind of a powerful thing, but for those of you who have worked in REPLs a bit before, what's the workflow like with this, right? You want to learn something, so what do? First thing you have to do sometimes is load a file, right? You load a specific file, and then you discover it's like, oh, OK, I load this, and it requires these other things. It has the imports and stuff like this. And you have some chunk of code that's available within the runtime at that moment, and you're able to go and ask the questions and do various different things. But how big is that chunk of code, right? And it's funny, so for me, working in REPL, sometimes I get surprised by how much I have to go and load in just to get to the point where I'm actually able to go and ask the questions I want to understand the behavior inside of the system. So is it better to have to load in the entire thing or a small amount of stuff? Which is better? It's probably better to be small, right? Because then you have some focus on the thing that you happen to be working on. And this thing that we have here, if you have to load in a lot of stuff, it's really a friction that kind of like comes up in the context of development. And it's something we really ought to pay attention to, because when we pay attention to the friction, often we can basically use that to inform the way that we're actually doing our design. So the big question becomes, how accessible are the parts of the system that we want to understand or change? Can we easily go and load them up in the REPL and do things with them? And then we have this thing as well of going and saying, how easily can we exercise and understand the behavior of the system? And there's a lot of sub-questions that basically come with these questions in order to go and understand, in order to see how to facilitate the best kind of work that we can do rapid work by going and, interacting with the system. So at the end of this, the main thing to recognize is that essentially when we are thinking this way, what we are doing is we are actually testing design. And this thinking doesn't come automatically. It comes from, as I mentioned earlier, paying attention to the pain or the friction involved in the things that we're doing. Now, I'm not asking you all to go and say, hey, I'm working a REPL, and stuff like that. But just to see this as almost like the metaphor for the testing framework. When you work in a testing framework, you are basically saying, I have these questions, find out what the system behavior is, stuff along these lines. Of course, these days now, with GPT, you can kind of like ask questions of it. What does my code summary look like? And it'll tell you things as well. But this thing of having a query interface, in a way, and we can see tests as a query interface to understand system behavior is probably one of the most valuable things we have when we're doing software development. Because the alternative is to sit there and just look at the code, look at reams and reams of code, and try to basically build a mental model about what's going on. We do still have to do this to some degree, but if we can go and sort of ask the question, what is the behavior when I do this? Then you're in a situation where it's just, it's going to be, it'll be much better because quite often you can actually delude yourself a little bit when you're reasoning through something. So the goal really is to go and basically have ease of understanding and ease of use. And the thing is to recognize that when we don't have these things, then quite often it basically points at something that would be problematic for us in terms of modularity. So in order to deal with this, let's go and first talk about some testing pains. Okay, things that are painful when we're in the context of going and writing tests. Have you ever basically had some method you want to work with, and what's going on with it is you kind of realize that it's like, well, there's something I want to know inside of here. Say I want to go and understand, did I format this particular thing correctly? It's kind of like what you can do is you can go way up to the top of the method and you can try to instrument it and understand how to go and actually hit that particular line and get that question. But, it's funny with this too, because often we want something a little bit more immediate than that, right? We'd love to go and understand what exactly is happening in this method. Could use a debugger, maybe, that's fine. But the thing is this pain that we have when we have the urge to go and find out something about the state inside of a method, does that indicate a design problem at all for us? Yeah, what's the design problem? Method's too long and complicated, right? If it was shorter, if we extracted out some pieces, we could test them independently. And then basically the interface that we have to the code becomes something which is human habitable. It becomes a thing that we can actually work with ease. Okay, another thing. This is like, I was looking for examples of difficult setup methods in tests, and this came up, and that's not very difficult at all, right? Have you ever seen setup methods that have like 50, 60 lines? Yeah. We know how to fix that though, right? We can use like all sorts of factories and all these things, and maybe we can collapse things down to maybe 1 or 2 lines and do all the setup that we need to do to go and run our tests. But is the problem still there? In a way, yeah. So when you have very, very complicated setup, does that indicate a design problem? What's the design problem? Well, it's funny. I like to go and sort of describe it this way. So imagine you basically go to like the Amazon, and you find a little tree frog, and you decide, I'm going to bring this back home with me, and I'm going to ignore the customs officers who are going to tell you this is a bad idea and maybe give you a fine for bringing wildlife from the Amazon to your country. So this frog is wonderful. It's nice, it's a great pet, and it dies in about a week and a half. Why does the frog die? Well, you know, it's got a different temperature, different humidity, probably very different food than when it has in the Amazon. And all of its friends are back in the Amazon. It doesn't have any friends here inside your little terrarium that you have in your apartment or your house. So this is a strange thing. Quite often we don't know until we take something and pull it out of its context what it really depended upon. And the same thing happens in the context of code, right? If you are trying to go and test some piece, some class or something inside your system, and then you discover, well, wow, if I want to instantiate this in a test harness, I need to instantiate this, 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 and this. And to instantiate each one of those, I have to instantiate the things it depends upon as well. And then you end up with this giant, giant setup. And this is an indicator of a design problem, right? Which we know is too many dependencies. And chances are, if the dependencies are really high like this, it's probably a good chance that your class is huge also, and it has other design problems. So this is a common thing that happens. What about this? Resource leaks? I mean, there's all different kinds of resources that can be leaked in systems. Some of my earliest graphics programming experience involved like graphics device context. And I remember working in a specific operating system where if you didn't release the GDIs that you were using, then things would crash later on and you'd have no control over it, right? And we do have automatic memory allocation now, but regardless, we can still end up in situations where we have resource leaks because of references and things like this. So it's a strange thing. When we have these kinds of resource leaks and stuff like this, we probably have our tests failing at times we don't expect for strange things. So what's the design problem? It's probably not cleaning up after ourselves, not going and creating like the encapsulation we need to go and say, to do this work, I need to go and have these things, and then guess what? I have to be polite, and I have to release these back to the environment. Make sense? So isn't it interesting? We're finding all these things that are painful in testing, and then we kind of discover that there's an associated design problem. And if we fix the design problem, then guess what? The testing becomes easier. And it's kind of a powerful thing. What about this? You ever have state leaks across tests? Where basically you have tests, and sometimes they pass, and sometimes they fail. It's kind of hard to predict, and you're kind of like, well, I expect some determinism, right? When I actually execute code, I want to actually know that I'm going to get the things that I want from it, and my code in production can't just sometimes work and sometimes not. What causes this kind of thing in a testing situation? Generally speaking, it's access to global mutable state, and it can either be singletons or other pools of resources and basically different data stores and stuff like that. And if you are actually accessing those particular things in the context of your tests, you have a bit of an encapsulation violation. The thing that you are actually working in is dependent upon something which is external and shared across all of your tests, and it's just kind of painful. So you should really go and sort of like find a way to go and at least make everything parameterizable in order to go and actually make things work well for you. This picture here is a picture of a terrarium, and it's one of those weird ones that you can't open. I don't know if anybody's ever seen these before. But they sort of say, here's a terrarium, and it's like it has plants in there, maybe a little bit of animal life or something like this, insects. And it's supposed to be fully self-sustaining as an ecosystem. But the thing is, you know that this thing is completely sealed, right? And in much the same way, the behavior that we have, that we're exercising in a test harness, should be completely independent of its environment. And if we're able to do this, then our testing is really, really easy. What do we need to do in design to make this possible? Well, we just need to go and actually structure our design in such a way that we can take one piece by itself and not have it depend upon external resources and other things that it really shouldn't be depending upon. So it points to problems with encapsulation, right? Here's one I'm sure a lot of you have kind of encountered. You have frustration when you're working in a framework, and you basically have like, you're using a particular framework and you want to test code that's integrating with the framework, and then you're like, well, where's my code? Because I see the framework code all intermixed with the code that I've got, right? It's a very tough situation to be in because you're like, okay, how do I test this? And then you're like, do I have to test the framework along with my code? And you get into all kinds of trouble with this. And it doesn't help that quite often framework developers don't think about the case that you might want to go and test your code independently. So does this indicate a design problem? Yeah, it kind of does. And the design problem is really like insufficient separation of concerns. It's really, really nice if you can take your core logic code and make sure that it's completely independent of the framework. And so things like hexagonal architecture and all these things will basically force this degree of separation. And it's interesting that if we don't have that degree of separation, our testing becomes really painful. So the pain in testing is an indicator of a design problem, right? So here's another one, difficult mocking. Okay, one of my favorite examples of this, which still persists to this day, is the Java Mail API. And it's really a great thing for going and explaining this particular thing. So in the Java Mail API, if you actually want to go and basically receive mail and check your mail and stuff like this, you have to go to a class called session, which is a singleton, call getInstance on it by passing it a property bag. And it goes and gives you a session. Then you go to the session to get a store, and you connect to the store. You go to the store to get the default folder, and inside the default folder is the inbox folder, right? So how many steps do you have here, right? If you were actually going to basically try to test this independently of really receiving and sending mail, testing it in process, right? You basically have to go to an object to get an object to get an object to get an object. Is this a design problem? Anybody ever hear of the law of Demeter at all? Okay, which basically says, don't go to an object to get an object to get an object in order to get the thing that you need, because it increases the dependency on the types all the way through, makes things much more complicated. So, you know, if you're trying to write tests of code that actually go and use something like this, you're discovering something which is a design problem. Maybe the better thing with this is maybe if the framework had some API where it's like, here, you plug in a listener for the inbox, and here, just call me whenever you have things, which is something's called the Hollywood principle in frameworks, right? Don't call us, we'll call you. Okay, other things. What about hidden effects? So you have some piece of software, and you want to write tests for it because you know it's doing some computational things, some rather deep things, but the answers don't come back to you through some interface. Instead, they get thrown into a database, right? Is that a testing problem? Well, I mean, you know, you can access the database in the test, too. Is that OK? Makes things really painful. It's going to be slow, and it's also like you're going to have to make all these API calls to go and gather the objects and stuff like that to go and understand, was the right thing saved? Does this indicate a design problem? Yeah, it does. The design problem is the insufficient separation of concerns. You shouldn't have your computation mixing with the things that are actually doing I/O in your system. The parallel to this is hidden inputs, right? And quite often the thing which is the common example of this is time, right? If you have some system and you find that you can only run the tests on May Day at 11 p.m. or something like that, then that's really a horrible situation. And we know that we can do things by going and, you know, changing the instance that we have, change the time on it in order to go and make the software run that way. But the thing is, it does point to another design problem, which is that we are depending upon something external, perhaps through the date and time API. And because we have those direct calls to those things, we're in a bit of trouble. So if we actually had abstractions around those things, and we can parameterize the stuff that we're working on by those abstractions, then we have something which is a bit nicer. And our tests can actually be much easier to write. What about this one? Unwieldy parameter lists. You know, you ever have parameter lists that have 7 or 8 parameters? You know? First off, that's kind of painful to write a test for, isn't it? It's like you got to remember what each one of the parameters are. You got to go and make up the data to go and put in there and all this kind of stuff. And so it's just painful. I mean, it's painful to call in your production code. It's painful to go and set up and use in the context of a test. And what's the design problem? Well, chances are it basically means that you've got too much going on inside that method or insufficient abstraction. And you know, once you kind of know this, then you're kind of like, oh, OK, I see the design problem. I can fix this, make my testing much easier, and guess what? Make the code a lot easier for people to go and use. The design characteristics become a lot easier. Slow tests, yeah, it usually means you're accessing something external, unless you're doing something terribly compute intensive. So yeah, there's 2 different cases for that. Sometimes it's useful to run these tests that are very, very compute intensive, but it's kind of hard to go and basically make something that's really that slow sometimes. But if you're basically going and using I/O and various different things, accessing external resources, then it's kind of obvious that if you actually break those connections and mock things out, then you're going to have something which is going to run much faster for you. So another case where testing pain possibly indicates a design problem. What about waiting? You know, anybody put sleeps inside their tests at all, ever? You know, yeah, right. And you know why? Because there's no decent API to go and actually figure out when things are done, right? So actually being able to wait on a synchronized call or something like that, maybe you don't even want things to be that way in production, but actually having the API to do something like that goes and makes these sorts of things much easier to go and deal with. You know, we shouldn't have to go and have this sleep, and if invariably the sleep is going to fail at some point, and you don't know whether it's because of some random scheduling thing or just because there really is a bug someplace. So this is a case where the testing is painful, the test execution becomes terribly flaky, and it's because of this issue that essentially you don't really have a proper interface to let the client know when things are actually done. And that's a rough situation. So here's the last one, insufficient access. Okay, so I'm just using a little bit of an example here. This is a class, and you can see we have one public method and we have lots and lots of private methods. So it looks okay, doesn't it? So you have this, one public method, lots of private methods. And what this thing really does is it accepts a string, it kind of parses it, it evaluates the string according to its own rules internally, and returns an answer back. But it's very strange to have a class like this where you have one public method and then you have a whole bunch of private methods. And sometimes they call this like an iceberg class because most of the mass is underwater in a way, right? So it's an interesting thing to notice with this. But the thing about this, though, is that sometimes you have the urge, you want to test something inside of this, right? Maybe there's this method here, it has more tokens, and I want to understand some odd case, some particular condition that happens inside there. So I'm kind of like, well, what do I do to go and format a string to go and actually exercise that exact, that exact case? And maybe the string is going to be non-obvious to go and do this. So you end up like looking at the test, and you're kind of like, okay, this is a test, and it's testing the tokenization stuff. And you try to look at the test and understand what's going on, right? And you see this crazy string, and there's nothing that's telling you why the string is crazy to exercise that particular small little piece of the code inside, right? This is very much like, I always imagine this as like, you're at the top of a well, and you're dropping a rock, and you want it to go and fall inside and land on one particular ledge. So it's a big, big thing of trying to figure out how's it going to bounce and land right there. Very difficult process to understand these things. Even when you have something which is giving you some nice feedback in terms of coverage and stuff like that. It shouldn't be that painful. So, is there a design problem associated with this? Yeah, I mean, when you look at this particular class, one of the things you realize is that essentially it's got many responsibilities, even though it seems like it has a relatively small interface, right? So we have evaluation as one responsibility. We have parsing, that's another responsibility. And we have tokenization, which is another responsibility. So if we cared about has more tokens, we can say, oh, painful testing. Let's not worry about testing right now. What are the design problems? Oh, many different responsibilities. So why don't we do this? Why don't we go and extract out a separate class? We'll call it rule tokenizer. And then this thing has these methods on its public interface. And you can go and call these things directly in order to go and actually exercise those particular things. Now, the funny thing about this is that once you show this to people and they're like looking at this, sometimes they don't really agree at all. They look at this and they're kind of like, why should I change my design just to make testing easier? And it's like, okay, well, it's kind of like, it's nice and stuff like that. And then the answer comes back, but I don't want that class. It's only used in one place. It's making my code lots of small little pieces, and it does no good for me. And I'm like, yeah, but it's like those responsibilities are kind of separate. And you know what? If we don't separate those things out, at some point in time, chances are these things are going to grow to the point where basically it'll be very difficult to understand how they interact and all the craziness that can happen in their interaction. So it is a design problem in a way. And then the thing for us is essentially just to go and actually, fix the design problem and then move on with this. So I've gone through a bunch of testing pains, right? They go and actually indicate problems in design. And the thing that's really kind of interesting about this is trying to understand why this happens, right? It's kind of like, why should it be the case that when we have pain in testing, we end up in a situation where there's an associated design problem? And fixing the design problem actually goes and fixes the testing problem. And this puzzled me for a long period of time. And one of the things that was really kind of funny is I thought, well, maybe the universe wants programmers to be happy, and that's why there's this correspondence between these things. Does it seem reasonable that the universe wants programmers to be happy? Oh, some people are saying yes. Wow, I need to talk to you after the session, right? It doesn't look that way to me. But the thing is that there really is something deep about this. And the deep thing about this is recognizing that most all the rules that we have for good design are really about our cognition. They're really about the way that we see and understand our systems. And so simple things like how much can you hold in your mind at once is like, okay, keep it small so you can basically just see this by itself. Is this thing tangled with other things? It makes it difficult to understand. Have as much separation as you can between other things. Keep the coupling low. Cohesion and coupling and single responsibility and open and close are all ways of going and approximating, or rather optimizing, our cognitive abilities in order to go and actually make some changes in code. And so it's fascinating with this. And I think I found a very pithy way of saying this, and that's that when you write a test for something, what you're doing is you're writing code to understand the code. And if it's hard to write code to understand the code, chances are it's hard to understand the code, right? So this is a wonderful thing for us because what it allows us to do, it allows us to go and actually learn better design by paying attention to the pain that we experience when we're doing our testing. And you know, that case before with the rule tokenizer, I remember talking to one programmer and it's like, no, I know what good design is. I don't need my test telling me. I'm like, no, flip it around. It's like, maybe this is great because you might have situations where you kind of forget or you don't see a particular thing, and your tests remind you that there's probably a different way of going and structuring things to make things better. And that's a nice thing to kind of know with this. So this thing of tests basically going and sort of like giving us indicators of modularity is really powerful. And I'd like to go and actually look at things from this point of view. Figure ground. Everybody's kind of seen this optical illusion here, right? So you see the vase, or you see the two faces facing each other and stuff like this, and it's nice. One little exercise I like to do with teams is to say, I want you to look only at the tests and then tell me whether the code is good or not. It's an interesting thing to go and think about this and think about how you can actually sort of, how much you can learn by looking at the tests and not looking at the code that's being tested. We know one thing already. The setup methods should be relatively short. They shouldn't bring in the entire world, right? If they do, probably some kind of dependency situation. If you have a bunch of tests, they're testing roughly the same behavior, the same group of methods, and it's a very, very long set of tests around those things. Maybe those things are big and complicated. Maybe you don't know. You're definitely going to see the calls to these methods because, you know, they're right there in the code for your test code. And maybe you'll see how many parameters are actually being passed across and stuff like this. So there's all these different ways of going and actually sort of getting a sense of whether the code is good or bad just by looking at the tests. And that's because these things really fit like gloves. And it's a nice way of going and looking at these things. I want to touch on something now which is kind of interesting for us, and it's the notion of like, you know, what is a unit in unit testing, right? For the longest while, we've been kind of avoiding the notion of what is a unit. We don't really want to go and talk about units much because units used to be functions, and then they were classes, and then we realized it doesn't quite fit. A video I basically recommend to everybody is this one by Ian Cooper. And it's basically TDD, where did it all go wrong? And I think the main thing that he was going and getting at is that we are testing behaviors. We're not testing one-to-one with a class. And this is something we learned with behavior-driven development and all these things. You know, it's kind of nice to go and recognize that. I think another aspect of this, too, is to realize that some languages are kind of like basically making this more obvious in a way. If you look at Go, for instance, basically the tests that you have in Go are kind of tied to the package that you actually have your Go code in. So you write a bunch of tests, they're in the package with the production code, you're able to go and run these tests. And it's kind of like, these are tests not just of like one little thing, they could be for one little thing, but it could be for the overall behaviors of the things that happen to be in the package. And so this thing of going and saying it's some cluster of code that we care about is kind of interesting. So the way I look at things now is that a unit is a portion of a system you can exercise and understand with tests with minimal setup or complication. Okay? So it doesn't necessarily go and correspond to class boundaries. It could. It could also be a service. You can say that I have service-level tests because I can understand through the API all the things I care to go and actually exercise with this. But I should have minimal setup and complication. So I want to move into something else that's kind of funny with this here. Y'all know aggregates from DDD, right? Very common thing, right? It's a very funny thing about this because there's a morphology. There's like an isomorphism between aggregates and quite often things that you'll see in other places. I found this definition of aggregate from a long time ago, and it really talks about transaction boundaries and stuff along those lines. But the way I kind of look at things is that, back in the early UML days, we talked about composites. You have an object that holds onto a bunch of other objects that it owns. And this feels like the same kind of thing that happens with an aggregate. But the other thing as well is to notice what happens in systems over time. And I call this factored out growth. It's kind of like you basically have a class, it gets big, you extract pieces out, and then you can use the original class as a facade in order to go and actually access the behavior that happens to be underneath it in a way. So in both cases, either you have like an aggregate case in DDD or something that's factored out over time, you probably end up having something like this. You have the base thing, which can act as a facade, and then goes and allows you to go and have access to all these different things. We can kind of flip this on its side and say, okay, well, what about testing? Test points. If I need to make a change to something, is it better to test through this facade for the entire object graph, or to go and dig down and basically deal with that particular object? You might have your options limited. It might be easier to go and test this thing directly than to be able to test it through the aggregate route. Does this mean we're violating encapsulation? Well, it's an interesting thing with this, because I think encapsulation exists at multiple different levels, and it doesn't always correspond to the constructs that we're actually working within a system. And that's actually okay. Here, we basically have another case where we might want to go and actually test this thing, which is almost like a little bit of a root, in a sense, to some other objects. And that can work out fine for us also. The important thing to recognize is that what we want to do is we want to test where our boundaries are. And what I mean by this is essentially, if you want to have a boundary, like an encapsulation boundary and stuff like that, you put tests in place around it because it's difficult to go and change those tests. People aren't going to want to do it, so it goes and gives extra oomph to that particular boundary. So it's like you're introducing a bit of friction to refactoring in a sense, and that ends up being the place that you see as the boundary of that piece that you're working in. And in order to go and basically do this effectively, what you can do is start to go and basically feel very comfortable with deleting and rewriting tests. And we're going to talk more about this in a minute. It's like people don't delete tests enough, right? One thing that happens over and over again, I'll have tests against some smaller pieces. I have a facade where I can test through. I discover I can move those tests from those small pieces to the bigger thing. And it's like, well, do I have to delete tests? That's okay. Turns out that writing tests for existing code is much easier than most people think. And we'll talk about that in a minute. So that's kind of like two-level testing. So let's talk about behavior for a second, because we've talked about going and fixing design, which is usually structural with tests. You probably run into this situation before. You're testing something to understand it, you find a bug, but it's never been experienced in production. Is that a bug really then? It's interesting, because someday somebody might actually do it. Usually it's some kind of like a little bit of a contract that you're not aware of inside the code, and it's never been exercised in a bad way and whatever. So you often have to go and rethink. It's like, what does it mean for us to go and have in this area of code correct behavior? Is this correct behavior? Do we have to fix it now? Using tests to go and document these cases is fine if we choose not to go and actually deal with them immediately. But the thing I want to get to with this is writing tests for existing code really is easier than most people think it is. The hard part is really breaking dependencies in order to go and actually write the tests for things. And then the next thing is letting the code tell you what it does. And what I mean by that is essentially this, okay? And I've talked about this, and I see teams do it now. Thankfully, they're doing more and more of it. This was a test I wrote for some piece of existing code, and look at the name of the test. Is that ridiculous? X. What does that even mean, right? So unlike TDD, when you're writing tests for existing code, you don't know what the behavior is going to be, right? So you write something, you put in a silly expected value, like an empty string here. You basically get that sort of thing back. You look at it and say, is this right? Is this wrong? Whatever. Doesn't matter in a sense because it is the real behavior of the system. Then you go back and you write a better name that goes and describes this particular thing. So this thing of going and testing things is understanding the existing behavior. And you can make notes about the things that you think are bugs and figure out when to go and fix them and stuff like this. But the writing of testing is much easier than most people think. And I just want give you all that as a takeaway, because often people think, oh no, writing tests is terrible. I need to play computer in my mind and figure out exactly what this is supposed to do. No, let it tell you what it really does, okay? So last and final thing here is just the primary message of this talk is that tests are also tests of modularity. But you don't get an explicit failure with these tests. Right now, it's just a matter of feel. You start to notice that things are painful. And hopefully, you work with some people and they get to point out pain that's going on that you're not even aware of because you think it's natural and normal, right? There's ways of going and reducing pain by going and increasing modularity or producing different modularity boundaries. And it's nice to go and actually just be aware of those things. So thank you very much. This is what I wanted to go and present to you all and everything, and we'll go on from there. Okay.
All right, everybody. Thank you, Michael.
Sure.
And get your phones out, your computers, your tablets, your desktops. Let's get on to Slido. So we got a first question up on the screen. How to fix test design?
How to fix test design? Well, I think it's, yeah, I guess that doesn't really get into this in depth with this particular thing. I guess the main thing is to basically think you can, if it's hard to write the test, think about fixing the code, the design first, and then making the test easy. So it's a matter of going and shifting emphasis to the thing that you are testing as opposed to the design of the test. The ease in test design should be a side effect of having good design around the thing that you're testing. Okay.
The next question, is code coverage still a relevant metric?
Yeah, I think it's relevant. It's a nice thing to know. You know, I think the terrible thing is for people to go and actually look at coverage and go and say that it's an important thing to try to improve in a code base. And I talk about this all the time with the case that happens with this. It's kind of like you can spend your entire career increasing coverage in a particular code base, and it won't matter to anyone. The important thing is to go and get the coverage in the areas that you're working in so you can basically increase confidence in what you do, and then naturally coverage is going to increase over time. But trying to get coverage in areas of code that you're not actively modifying just to go and get the number up, bad idea.
That's right. It's kind of like it's good to have the metric but not obsess over it. Right?
Exactly, yeah.
Next up, what is your opinion in end-to-end testing regarding fixing design with tests?
I think at that level, you don't really think. I like to basically make sure that, oh, here's the thing. If you get to the point where you're basically going and asking something very, very specific in an end-to-end test, and you really need to go and understand more about how that's actually happening, quite often it's going to force you to go and write tests that are closer to that behavior or tests closer to that behavior. So it does give you some indication. If it's really kind of hard to exercise all the functionality of an end-to-end test, you're hoping for some modularity internally that you can actually go and work with. So.
Got it. And maybe the third one. I spent a lot of time learning about TDD, clean code, refactoring, and the like. Do you think this is still valuable knowledge to have in the times of ChatGPT? Another AI question. Okay,
well, I can give you an answer, but this is 19th of May, 2023. So anybody looking at this later can know that I'm speaking from a particular context that we have now, and it's different, right? So, of course, it's going to be very stale knowledge at some point in time. Right now, the context window, the actual text that you work on in order to go and solve problems, is relatively small. It's going to get much bigger and bigger over time. The big question really is, how long do we need human people to actually look at the produced code and basically understand it well enough to go and know that this is the right thing? And I think as long as that happens, we're going to need to have the skill of understanding cohesion and coupling and all these different things. I think even if we didn't have to look at source code, things like cohesion and coupling are part of all engineering disciplines, okay? The way that pieces interact and stuff like this. And I think anything generated by AI, if it's going to involve the connection of different things, there are going to be people in the world that need to go and be aware of these particular things. So.
Yeah, especially talking about design, right? Knowing these kind of things will help you actually kind of evaluate what ChatGPT puts out. So it's
totally,
very, very relevant. All right. What about this one? Should one write a test somehow for hardly testable code, or may one change the code first to make it more testable? What if such a change is far from trivial? That's 3 questions, maybe.
Well, there's this book that was written 20 years ago by this guy, Michael Feathers, right? And the entire last part of the book is about 24 different dependency breaking techniques, which are technically refactorings, but they are refactorings that are so obvious and visually verifiable, you can feel comfortable doing them without tests. So I think there's that thing of like digging in and understanding how you can break dependencies well enough to get the piece that you want to write tests for. And I think that that's practicable in most cases. So.
Perfect. I like this next one. How do you measure quality of a test?
Measure what?
The quality of a test. It's not here.
Oh, OK. Yeah, measuring the quality of the test. It's readability. It's understandability for the most part, right? People used to have this one thing of saying only one assertion per test or something like this. Do you want to do this? You can have multiple assertions if you want to. The thing is, you should basically, when there's a test failure, understand exactly what led to that failure. Understand how the code needs to be set up in order to go and actually evidence that failure. So if you're looking at a test and it fails, and you have to go and say, how did this happen? And it's like, what's going on? What does this even really mean? Then that means that the test can be of higher quality, usually smaller, better named, and with a design which allows you to write those kinds of tests.
And I also like the way that you were thinking about, like, from the test, can you figure out if this is good code? I think there's another kind of quality type of...
Fair enough, yeah.
And then maybe one last one. If you want to figure out how a piece of code works by creating tests, how do you specify the inputs used to avoid useless test scenarios?
A lot of it just has to be intuition or understanding a little bit about the system. But I often like to do this thing of putting in stupid things first. So I will actually throw nulls into tests just to understand, what does it do? Is this behavior even exercised in a sense, or is that variable exercised? I'll never leave it that way. But you try to go and just sort of think about things that you would need to deal with. The main thing I kind of point to with this is it just is a matter of curiosity. If you are curious about what's going on, then you're in a problem-solving mode to understand what kinds of things you need to go and pass to go and get what you need. Some of it involves the code reading or getting information from other people and stuff like this, too.
Got it. Thank you. Well, one more round of applause for Michael.
Thanks.